Good afternoon, everyone. My name is Andreas Bowman. I'm the Vice President for UW IT, which is a central IT function at the University of Washington, and I'm also the University CIO. Welcome to this AI Perspective speaker series. I'm really excited to be here today. I really appreciate this speaker series in that it takes a very broad view on artificial intelligence, some of the concerns, some of the exciting things. And with us today, we have a great speaker, Dr. Chirag Shah, who is a professor in the Information School here at the University of Washington. He is also an adjunct professor in both the Paul Allen School of Computer Science and Engineering and also Human-Centered Design and Engineering. He asked me to keep this short, so I will. But I just want to emphasize the honor we have to have Dr. Shah here and his long list of accomplishments. With that, I will turn it over to you, Dr. Shah.
Thank you so much, Andreas, and I'm so glad to be here. I also want to have a shout out to Andreas and his team, especially Jared, Melissa, and many others who are doing this incredible work at UW, running this AI task force. There is a lot of interesting and important work being done, and I thank them not just for this speaker series and inviting me here, but all the broader set of things, efforts, and leadership that they have. So great being here. I'm gonna start sharing my screen. As I talk, as I go on with this, if you have any questions, I really welcome. I want to see those. And so please send those questions to townhall@uw.edu. So today I'm here to talk about agents. Now, this is something that perhaps you have already heard about or you're very familiar with, but there's a lot of uncertainty, a lot of questions about it. There's also a lot of hype. There's a lot of excitement. There's a lot of fear too. Now, I come from a place where what I describe myself as an AI pragmatist, which means I'm not here to hype things up. I'm not also here to create fear about it or argue that this all should be stopped. What I'm interested is to look at this phenomenon and try to tease apart what are some of the fundamental opportunities and challenges in this, and what does it mean for us? So part of my talk today is a bit of a historical perspective. Part of it is a bit technical, and the other part is more philosophical. Though I have to warn those who are into history or technology or philosophy, this may not satisfy none of you, because we're not going to have a chance to go deeper into this. But I hope that I at least get the conversation started. So when it comes to agents, the first thing is, like, what is an agent? And this is kind of similar to defining an AI, right? So over the decades, the definition of AI or understanding of AI has shifted. And similarly, today, what we think about agents, we're not always called agents. And yet we can look back and say, oh, that was an agent. Right? And so as I go on, I want to be mindful of what is even agent. But an agent typically is something that acts on its own, that you can delegate a responsibility, and this entity can take decisions to solve problem that you have or the task that you have. For instance, you can have an agent that's a drone, automated drone, right, that goes and carries out mission. Now, what if this drone, in the process of carrying out this mission and making these decisions, make certain decisions that go against what you would like to see? So this actually happened some time ago in a military simulation, and I have to emphasize that part. This was simulation, where a drone like this that was being simulated to go and destroy a target decides that one thing that was hindering its ability to destroy the target was the operator of that drone, because the operator has the ability to call the drone off even after giving it a target. And the drone is designed to self-learn and go over any obstacles. And a lot of these things you cannot program. You have to let the drone decide on its own. It's an agent. And so in this simulation, the drone decides to take out the operator. Now, obviously, this is not a good scenario. And so, I mean, that's got to be a quick fix, right? Because you put that in the code, don't kill the operator. And so they did that. And sure enough, the drone doesn't kill the operator, but it decides to take out the communication network. Without the communication network, the operator cannot communicate to the drone and send the kill signal to not destroy the target. So again, in this situation, what happened, the drone that was designed to self-learn and decide, figured out a way around some parameters. Now, military also then later denied doing even this simulation. So we would never know if even the simulation was real or not. But something like that has been mentioned many years ago. So Nick Bostrom, a Swedish philosopher, more than 20 years ago, talked about a scenario, and this was a thought experiment where he talked about a paperclip making agent. So you have an agent that's sole task is to make paper clips, as many as possible. And then he goes on to talk about how if this agent is really smart and super intelligent, then it will go on creating paper clips from every possible way, including starting to use the material in that room, in that building, on the planet, and ultimately ends up destroying the universe. Now, of course, this is far-fetched, but it was a thought experiment. We're starting to see some of these things now starting to take place. So here, on one hand, we want to delegate our tasks, whether it's making paper clips or field work in different domains, including in military operations. But on the other hand, there are these dangers. And so these things on both sides, you can make a case for going for it or shutting it down. But whether you like it or not, when you look around, these kind of agents are starting to pop up in many places. And these are just some random examples. And the reason these are random examples is because I've taken random samples from big tech as well as mid-sized companies, different domains, and startups. In fact, when looking around, you see many evidence, many data points that point to people's enthusiasm for building agents. Like this IBM survey found that most developers that they surveyed are exploring or already developing AI agents. This year is identified as the year of AI agents by multiple analysts. Agentic AI has been named as a top tech trend for 2025. So on one hand, there are these scenarios where there are clear dangers. Maybe some of them never happen. Maybe some of them could happen. But we are already building technology that could enable something like this. So today, we're going to talk about what are these agents? Why are they being built and deployed? Where are they being built and deployed? Why do we want them? And how do we develop and use them responsibly? So once again, my aim here is not to say, this is all bad, let's never do this again, or this is so amazing, let's go ahead all in, but to really carefully think about why do we want to build these things, how can they be used, and more importantly, how they can be built and used responsibly. So one of the things, and this is a kind of a self-serving plug I would put in, we have the Center on Responsible AI at UW called RAISE. And these are some of the things that we care about. We want to think about this technology, whether it's AI or not, we want to think about responsibly and ethically building and using them. So before we get into a little bit of history of agents, now, as I said, agents were not always called agents. But what are agents? If you were to define it today, it may have been different 10 years ago, but if you were to define it today, agents is an entity which is typically a program that takes different preferences, instructions, or other kinds of inputs from a user to do tasks on their behalf. And this is kind of an important thing, that typically you're delegating your task to an agent. Now, because in this context, it's clear that when I say agent, I'm referring to AI agent, but other contexts, we also call out AI agent as a separate thing because there are also human agents. So human agents also go out and carry out tasks on behalf of individuals, organizations, governments, and so on. These could be simple systems. Your thermostat is a form of agent. It's carrying out some simple task, but it could also be something complex like self-driving car. But these things are autonomous. They act both reactively and proactively. And they don't always go by this name agents. Sometimes they're called skills, they're plugins, they're apps, operators, and so on. In fact, those who are in the Unix world, sometimes they're called daemons. So if you look back decades ago, agents are as old as AI itself. This is one of the early examples, which, of course, back in those days, they didn't call it agent, but what this was, it was a program that could do theorem proving. Theorem proving, something that is, at least at that point, was considered to be a human endeavor. But this program could take theorems from this Principia Mathematica and prove more than half of those theorems. And in some cases, it can actually do a better job than humans. So this is one of the earliest examples of an agent. Another important example from the history is ELIZA, which many of you may have heard about. This was one of the first, or maybe the first, chatbot that you can interact with, of course, using a text terminal, but can carry out conversations. Shurtulu, or however it is pronounced, actually, it's not an acronym. It doesn't mean anything. The inventor, Vinograd, just made this up. But that was an agent that you can use to have some object manipulation, like you see here. Then in the 1970s and 80s, we had a whole bunch of expert systems that did things that normally humans would do. So medical diagnosis, for instance, MySyn was an example of that. But there are many other examples that were primarily rule-based systems, but these things carried out tasks, decision-making typically, that would normally be carried out by humans. Then comes the age of what I would call modern agents. So from the 1990s to early 2000s. And these things started having something more sophisticated than simple rule-based things like BDI, or the Belief, Desire, Intention framework. Some of these were reactive agents, or most of them are reactive agents. Some were software agents. So I mentioned daemons, or like other processes in even the old Unix system, but also newer systems that started integrating agents into operating system, desktop, as well as mobile operating system. Multi-agent system started becoming a big thing, where different agents connect to one another and be able to solve complex tasks. And we'll come back to multi-agent system in a little bit. Some special mention, I would say, are things like web crawlers. In the 1990s, as the search engines and other systems were becoming a bigger thing, the web was becoming a bigger thing. The web crawlers will go out and collect all this data on behalf of the humans and index it and so on. Clippy is a classic example of an agent. And if you don't know that, if you didn't have a chance to live through that, you missed out a lot in the 1990s. But maybe this jogs your memory. It was an office agent that popped up on your screen when it detected you were writing a letter or do something structured that it recognized, and offered its help. Of course, it was found to be annoying overall and was canceled. Roomba in early 2000. So these are some agents in different environment, in different systems, for carrying out tasks on behalf of the humans. So they are doing the things that normally humans would do, and humans can delegate their tasks to these systems. Then we had what I would call the AI winter for agents. So in the 2010s, because what we saw is some of these things were starting to hit the limit. And that includes things like Clippy. I mean, Clippy was kind of long gone before 2010s, but even the other systems that stuck around, they were starting to hit the limit. They hit the limits not in just like ability to do tasks, but reasoning and just overall intelligence. So here's an example with Siri. What month is it? And Siri responds, sorry, I don't understand. Now, this is actually not that old. This is only about 2 months old. So this example comes from 2025. And in fact, just before this talk, I thought I'll test it out, see if it's changed. And I talked to my Siri to ask me this question: what month is it? And the response was, today is Thursday, May 8th, 2025. So it didn't say I didn't understand, but it was clearly a wrong answer. And perhaps you can also give it a try. But this is 2025, and we are still struggling with something as simple as that. These systems, Siri, Alexa, and Google, and some others, they've had integration difficulty, right? Integrating into mobile phones, that's one thing, but other systems and cross connection. And for the most part, there have been big commercial disappointments. There are staggering numbers about how many billions of dollars have been sunk into these things with not nearly as much return. I mean, I go around talking to people, asking them about how they use their intelligent agents like Siri or Alexa and other devices. And the kind of things that they're doing are something very simple, like setting a timer or playing music, things that after billions of dollars and this many years of investment, it's a very, very low bar that we've reached. So there's this kind of a AI winter that happened, but then things started changing. And so now where we are, and this is what I want to argue, that we are in this AI agent renaissance. So what is this new age of agents? Well, elephant in the room, foundational models. Now, these started becoming quite popular in the last 5 to 7 years. And because of that, and because of them being at the heart of these systems, things have dramatically changed. We started building better and better reasoning capabilities. These agents are no longer just carrying out their defined tasks, but they're able to extend their capabilities by using and calling tools. So an agent can call web search, can call calculator, can call APIs, and so on. And that way it enhances capability by many, many folds. These agents are able to also do self-reflection and improvement. And I know some people may not like this idea of self-reflection because it seems it's something that should be very human. So whatever you want to call it, but there are ways for agents to do a lot of self-correction. And there are a bunch of specialized architectures. We'll talk about those as well. And the multi-agent systems have made a comeback in a different form. And again, I'll talk about that too. But I want to take a little sidebar that in my lab, we actually had a multi-agent system that we shut down in 2020. It's called IRIS, stood for Information Retrieval and Interaction System. And this was a description that it was a system that allowed connecting lots of small modules or agents to build something more complex, right? So, and this was inspired by Minsky's work. It's called Society of Mind. It's a great set of essays in which Minsky argues that mind is not one singular entity that's smart, but it's made up of lots of little things that are all kind of not smart, pretty dumb, but it's the way those things are connected that's what creates something more sophisticated, complex, and smart. So anyway, so it's just a little sidebar. But coming back, we see now agents actually making impact. They're being used in the fields. These are just some examples, like ChemCraw in doing drug discovery and material design, Ada, for doing customer service, Silence and CrowdStrike's Falcon for internet security. Cubicycle, it's used for supply chain management. And so it does traffic analysis, weather patterns to optimize delivery routes, many, many examples. And these things are no longer just lab projects. They're not just prototypes. They're actually being used actively in the field. And so why is this a renaissance? Why is this a better time of all the times? Maybe, we are once again euphoric about something, like back in the days we were about Clippy. Well, there are certainly some signs of something big happening. So there's quantum leap in capabilities. These systems are no longer bound to singular tasks or simple tasks. They're able to do complex tasks. They're able to enhance their abilities. Um, they're already being applied in multiple domains. There are frameworks in place, and this is very important, that these are not just some programs that a few entities build up. There are frameworks that others can take and build their own capable agents for that particular domain, like LangChain, AutoGPT, LangDroid. These are the things, and there are many others that are available for people to build and deploy their own agents. These things have greater autonomy. They can these agents are now starting to do web search. They're starting to do kind of the tasks that allow them to bring more information in the mix. They also offer a great deal of personalization. So agents are already here, whether they like it or not. And so when I go around asking people, I'm meeting people mostly in tech industry, and not even tech industry, but even in healthcare and finance and other places, they all want agents. They want it now. But when I ask them, why do they want them? And you hear all kinds of different answers or not clear answers. How do they want them? And again, you kind of get mixed, things. It's almost like, oh, because that's the trend. That's what everybody's doing. And we need to be doing this. And so this is a bit of that hype thing. So that's definitely going on, where not everybody's clear on why they should need agents, why you should have agents for their organization or their individual use, and how it should be integrated or implemented. They just know they want it, right? It's a shiny new toy. And then, of course, not enough or hardly anyone thinking about then what? So even if you're successful with all these things, what does it mean? So for the rest of the talk, I want to focus on these three aspects, right? Why do we want agents? How do we do that? And then what? And I will argue that the why should be really about the users, context, and tasks. So we shouldn't be doing this agents until unless we know enough about our users or ourselves, context, and their tasks. How do we do this? Well, if you're doing this, it needs to bring enough personalization, proactivity, but it also needs to ensure privacy. And then finally, we need to reflect on what does it mean if you're successful doing this, if all of this works out, what does it mean for us? And so I want to reflect on these 3 points, starting with why do we do this? Why should anyone care about agents? So I would argue that agents, before we get to the agents, because agents are this autonomous entities that carry out tasks on users' behalf. Okay, great. But what are those users? What are their tasks? What are those contexts or scenarios? So we need to understand that. The good thing is we have decades of research in doing those things. Those things may not exist in the field of AI, but they've existed in other areas. So we can learn from those places. For instance, here's an example of how we think about tasks. And this is a very simplistic explanation, but it's an explanation where it said, well, look, people have this higher level goal, like planning a vacation in Paris. And that includes booking, my flights and booking hotel and stuff like that. And ultimately, it comes down to taking some action where you go and maybe search for something or click somewhere and book something and so on. And so how do we better understand this? And there are these 3 kinds of understanding you can do depending on how you traverse in this tree. So if you're going from top to bottom, it's an issue of, it's called task decomposition. So knowing a bigger task, how do you come up with subtasks and actions and so on? If you're going bottom to up, then it's an issue of task recognition. So if somebody gives you a query about compare hotels in Paris, what do you think they're doing? So building it up. And then if you go sideways, it's a task prediction issue. So if somebody booked a hotel for Paris, understanding that maybe they also need flights or maybe also need to look at sightseeing, those are task prediction things. Again, this understanding has existed outside of agents and AI. but we can leverage that. We can also leverage understanding context. So imagine this scenario where somebody is driving and they're in a context where they can't use their hands or eyes to do something. And so they're able to speak and say, hey, my niece's birthday is coming up. Can you look up some present ideas? And if there is a system that can capture that and comes up with some ideas that the user can get some notification while she's walking, out of her car, and now on the phone there's quick notifications and she can take some quick action. Well, that doesn't look good. No, not that, but that's interesting. Go look more. And then the agent or system goes away and does some more research and brings up more information that the user can access on her laptop. And then later, as she's engaged in different contexts like cooking or something, once again, communicating through voice. So these are all different contexts, but the same task. Right? And so the question is, can we understand and capture the same task, even if they're different contexts? And given the context, can we do the right kind of interactions? We can also go across modality. So modality is a combination of the interaction style, the device, and so on. Monomodal is just when you have only one way to interact. But many times we have multiple modalities. We can maybe text and call or talk. We can use a mobile device. We can use a desktop. Right? Cross-modal is when people start the task one place and finish in the other place. Right? And more interestingly, transmodal is where a user is able to go across multiple devices seamlessly without having to worry about where it begins, where it ends, because all of those devices, all of those interaction styles are able to accommodate their needs. So an agent could be an entity that can provide this, what we call pan-modal support. So whether it's multimodality, cross-modality, or transmodality, without the user having to think through or think about these things, right? We can delegate this thinking to the agent that can make these choices, decisions for us. And so we can just focus on our task without having to worry about what context we are operating in, what modalities we have available, and so on. So the agents, in this case, a compelling case for having an agent is something that we can just delegate the task and agent takes care of all this context and the modalities and so on. So earlier we talked about going up and down in this kind of a task tree, but you can also imagine with the help of agent, we can go up and down in this need hierarchy. So at the bottom level, we have this physiological needs and then the safety needs. If those are accomplished, if those are taken care of, maybe we can focus more on the love and belongings and esteem and self-actualization. So perhaps agents could be built to help us get done with some of those lower level things so we can focus more and more on the higher level needs. So that makes a better argument for agents rather than, oh, because we can build agents and everybody's doing it. How do we do this? So the problem is, even if we're building this capable agents, we may still, once again, run into what happened to Alexa and Siri and others, where the agent is capable, but it's never good enough and never integrated enough. So just having capable agents are not enough, even if with the right motivation. Because here's the thing, even though we are excited about LLMs, that's not the answer to everything. And so today it may seem like, oh, we can just quickly, build up an agent with some LLM or some foundation model, but that's not enough because we're too focused on what the technology could do and not what it should do. To answer what it should do, we really need to focus on the user side, because no matter how much higher capacity or capability these things have, it's still not going to be enough for doing personalized tasks. Even when you have multi-agent systems, so the advantage of multi-agent system is you have multiple agents, each of them doing different kinds of tasks. So when you put them together, you can accomplish something complex. Great, but even then, you need a good coordinator or orchestrator that can connect with the user's task and context. So what do we still need beyond this agents? Well, we need to be able to interconnect and separate this public and private agents. And I'll come back to this in a minute, what I mean by that. But we have agents that could get things done, but we also need agents that could that we can keep closer to us. We can share private information and know that it's not going to leak out, that it's not going to go to some cloud or be shared without your knowledge. So we need methods for personalization without compromising privacy, because this is the kind of trade-off here, that the more personalization we want, the more we have to share about ourselves. But so how do we do that without compromising our privacy? So we need these kind of methods or techniques. We also need techniques that allow us to interact with the agents in just the right amount of manner, because the idea behind an agent is you're able to delegate your task, and then agent goes off and carries out your task. But there's a risk there. What if the agent makes a mistake? Who's accountable for it, right? And so it would be good if the agent were to come back and confirm with you. But if it keeps coming back and asking you all the questions, then it kind of defeats the purpose of having an agent. So you also need to figure out what the right balance is. And as agents become more capable and we delegate more things to these agents, there is also need for transparency and accountability. So there are all these issues. And so here's a proposal that we have for addressing some of this. And this is still little at the proposal stage, but we need something like this. And the proposal calls for the separation of the public agents and the private agents. And what I'm showing here, the agents are these public agents. So these things exist maybe in some app store, they exist maybe in cloud, they're available for anyone calling them. But then there is this special kind of agent called assistant, and the assistant stays with the user. So it could be something that's just on device, right? But it stays with you. And this assistant has access to your private information. And that information is just not any kind of information. It's presented using what I'm calling SIM. So a SIM is a representation of a user. I'm an educator, so I have a representation on that aspect. That's one aspect of my life or personality. I'm also a father. That's another aspect of my personality. I have hobbies, I have personal life, I have friends and so on. So I could have multiple SIMs, each of them capturing different aspect of me, as well as my behavior around those things. So what is my parenting style? What is my teaching style? So these are in different SIMs. What is my past behavior around shopping for my kids versus planning business trip and so on. So these things are captured in the SIMs. And again, they also stay with the user. So these are private things. So when the user has a task, the task goes to the assistant. The assistant doesn't need to ask a lot of clarifying questions because the assistant has access to the user's SIM. So the assistant already understands enough about the user, their context, and so able to then refine this task to that specific time and need through maybe some interactions. And then once the task is clear, it can go and do the task on behalf of the user using other agents, services, whatever is available. So what does this look like? Let's take an example. So here's a scenario. Alice wants to look for some after-school activities for her 9-year-old daughter, Hannah. Now, can Alice take this to give it to any agents? Perhaps not, because you go to somebody and say, well, find activities for my daughter. Well, they will have a lot of questions for you. And so they can't act without Alice's intervention. And even Alice may not know everything about the task. So in other words, it's not going to be as simple as just like, go find activities for my daughter. But with the architecture that I showed, we have some demos, and this is what it looks like. So here, Alice says to her assistant, I would like to find some after-school activities for Hannah. And in return, what the assistant does, it starts coming up with the refined understanding or personalized understanding of that task. And this is what the assistant comes up. Alice is looking for these activities for her daughter, Hannah, who's 9-year-old and has ADHD. So notice that nowhere in Alice's original request, she said anything about who Hannah is. But the assistant knows that Hannah is Alice's daughter. She is 9-year-old. She also has ADHD, right? And then it goes on to describe the task. And considering her free time from 4 p.m., again, Alice never said that. but assistant knows enough about Alice to get this. And then there's more details here that I'm not displaying. And when Alice sees this description, and she's like, huh, I actually want to have her some physical activity. So not just any kind of after school activities, but physical activities. And then so assistant revises that task description and said, okay, well, find some activities that positively channel her focus. So this is again responding to Hannah's ADHD. But Hannah doesn't like soccer, so we need to find her some other sport. Again, Alice never said this about Hannah, but assistant that has access to Alice's Sims, where she has a sim about her family, in which there are all these preferences about what food Hannah likes, what activities she doesn't like. It is all recorded and also the behavior there. So assistant is able to make these kind of decisions without having to explicitly get feedback from Alice or ask Alice. And Alice can see in real time what the assistant is coming over. So any place when she thinks it's inaccurate or wrong, she can intervene, but she doesn't have to intervene a lot. She doesn't have to specify a lot. So after maybe 2 or 3 of these interactions, Alice is happy with the assistant's characterization of the task. And at this point, the assistant can go out and find web agents, browsing agents, other kinds of services online to start doing this task on Alice's behalf. And when it's doing that task, it doesn't need to share private information. So for instance, it doesn't need to say that the person's name is Hannah, because many places you wouldn't need that name, that Hannah is exactly 9 years old. Most places it can pick the range that Hannah has ADHD. Assistant will use the information that Hannah has ADHD and look for those activities that fit to that need, but doesn't need to give out that information for that medical condition. Here are some other examples. So these are some simple demos that kind of show that we can start to do this if we focus on the user and the context, keeping that privacy, and then leveraging where the agents have the right capabilities. There are a bunch of new challenges that we still need to do. So don't get me wrong, this is not all done deal. There's a lot of new things we need to address now. One of them is, how do we evaluate? If the agent does something, how do we measure that this was the right thing, this is a good thing, this is the right cost, and so on? If we expect this to be personalized, if we expect it to be proactive, we also expect the agent to give us recommendations even when we're not looking for it, right? Be proactive. And so how do we measure those things? We don't have good benchmarks, data sets for doing these things. Creating protocols for this cross-connection compatibility. How would 2 agents designed by 2 different entities talk to one another, take advantage of each other's capabilities? And this is different kind of multi-agent system than the multi-agent systems we have seen so far, right? And then, as I said, as we delegate more to these agents, we need to have more transparency and accountability. Speaking of which, then what? So even if we are able to do all these things successfully, where we build not just capable agents, but the whole ecosystem around that, where we build these protocols, where we build this agent stores like app stores, where we train people to use these things, then what? And this is something that we haven't really thought about enough. We haven't gone enough, and not many people are really thinking through this. Because looking back to that scenario, while it didn't really happen, maybe there was a simulation, and the Army even denies that. It didn't really happen, but we're not that far from something like this happening. There have already been cases where these kind of agents have done things that go against human values. That's something that we would not want to do, but it's already starting to happen in different domains. How do we prevent for those kind of things happening? How do we live with something like this, where there are more and more capable agents are popping up around us? And so let's talk about it. What does it mean for us to delegate our tasks? And that kind of comes to some fundamental questions about ourselves. So this is not about technology. This is about who we are and what we want to be. Because a lot of things with not just agents, in general AI, and in general with technology, we see these as, or we want to see them as our tools. That's something that we can use to augment our abilities. In some cases, provide us automation. And we have a whole history of doing this, from the early era tools to industry revolution to technology revolution, and now this AI revolution, to use these things, to these developments for augmentation, automation. But there's also this third element, which is evolution. Do we see this? How do we see this fitting in our evolutionary trajectory? And that kind of brings us to the question of where do we see ourselves going, our society, humankind? And so the fundamental question is, when we do these tasks, the tasks that we want to delegate to these agents, why do we do these tasks? So an example is calculator. Right? Calculator is an example of augmentation. It allows us to expand our capabilities because we don't have to do those long divisions by hand or in our head. We can use this tool, and that speeds up the real bigger problem that we want to solve. And it's been well accepted, the use of calculators, even in schools. But we still teach elementary schools multiplication tables. Why? Eventually, they are not going to require to do multiplication in their head. They can use calculators, well accepted. We still teach those multiplication tables because we believe that the reason for doing that is not to be able to just simply do multiplication in real life, but it's a part of training our brain. It's a part of our upbringing, cognitive upbringing, right? And so we've accepted that. So we teach multiplication tables, and yet we allow kids to then use calculator. Similarly, we have to ask, if you're doing something, are we doing it because it's a task that just needs to be done and there's no greater purpose for this? Or is there something more to it? And so when I think about, personally for me, as a father, I, go drop off my kids every morning. And that takes, some time, just a few minutes out of my time. That could be a task I could delegate. That would be great. But when I reflect on it, why I do it, when I take my kids to that, their school, and I talk to them along the way. I talk about how their day is going to be, what they're excited about, and so on. I drop them off. I see them running off into that door, and it kind of gives me some sense of satisfaction that there they go, out in the world learning something, and I can't wait to get them back, and then so on. There's something about it that kind of connects me to them at a level that's not simply doing a task of dropping them off, right? But that's something for me. For somebody else, it may be something else. So we have to really ask, if I can delegate this task to an agent, what am I losing by doing that, right? And this has implications on our individual identity as well as identity of our society. What does it mean for our economy? What does it mean for our workforce and education and so on? So we haven't thought enough about this. We haven't thought enough about how do we make sure that these agents don't go rogue, like that drone scenario? Because there are always this tension, value tension, or trade-offs, privacy versus personalization, or how much agency we want to give them, and how much proactive they are going to be, how much we want to have control over things or let go of the control and trust these agents. So we don't have good frameworks for doing this. Everybody's making up their own stuff. So you can, of course, ask, well, what about regulations? Well, let me just say that so far we don't have anything that gives me assurance that regulation is going to work, or there's going to be enough and the right kind of regulations in every country that will help us do this responsibly. And so in the meantime, we are stuck with figuring things out on our own or doing things in our own silos. And so I've been thinking about this, and maybe there's this little framework I can provide, even though it is very at a high level. So I give 3 principles. The first one is conformity. That these agents, as you're building, we have to ensure that they conform to our values. That it is not okay to take out that operator, even if it means you fail your mission. Right? It is not okay to destroy the universe, even if it means that you can create tons of paper clips. Some things that are just common sense to us, it hasn't been to these things. And as much as we are excited about their reasoning abilities and tool using abilities and multi-agent systems, these simple common sense things haven't been able to convey to them. And so that needs to be the first thing, conformity. We have to make sure that these agents are compliant on that. Second, of course, these agents are going to go out and do things that are not going to be easily programmable. So they will face some of these challenges, some of these trade-offs, some of these value tensions. And when they do, we require them to consult with us. How do I make this choice? Come back and ask us, because this would be useful not just for us to have a better understanding, control of, and making sure that the agents don't go rogue, but perhaps it's good for us too to reflect on some of these things. What do we value more? And often we are making these choices, politically, socially, in all kinds of ways. But I think it's important that we continue that conversation because we're still learning, we're still evolving. And then finally, agents need to be in this collaboration mode. That sure, they are going to go do things on their own, but it's sort of like having a co-pilot. And so the pilot uses co-pilot for flying that plane for a while, but it's understandable that ultimately the pilot is responsible. The co-pilot is, autopilot is working in a co-pilot mode, and the pilot can get the control back. So it needs to be done in a collaborative fashion, even if sometimes in collaboration means you give complete control to the other, your partner or the collaborator, but you know that ultimately we are working together towards the same goal. And so the agents don't have their own goals, but the goals and the tasks that the user has. Of course, this is all easier said than done. And there are a bunch of things that I didn't talk about that are still big issues. So I just want to, as I wrap up, I just want to make sure that I also reflect on things that I didn't talk about in this. So again, I want to make sure that I'm an AI pragmatist, and that's reflected here. So I didn't talk about the environmental impact. This is again big thing, and not just agentic space, but in general AI. A lot of these tools that we're building, we're not necessarily thinking about the cost, not just the dollar cost, but the environmental cost. And so I didn't talk about that. I didn't talk about fairness or inequality issues. A lot of these things have potential to create great value collectively, but that doesn't mean everybody will gain equally. There are a lot of inequalities that these things create. There's a lot of haves and have-nots and must have, must not have not kind of thing. And so I think it needs to be acknowledged that even if overall there's going to be progress and positive development, not everybody's going to benefit. And it's very possible in many cases that some people will benefit at the expense of other people. I didn't talk about the economic models. These things, who's paying for this, right? And so currently we are, some of these agents that we have are kind of given to us free, quote unquote free, or at a very dirt cheap price, but they actually cost a lot more to run and build and so on. So at some point, somewhere, we need to figure out who's going to pay for this and how that's going to happen. This is a different model than, say, search engines or social media services where you have ads generating revenue. And so, we still don't have enough understanding of it. And, it could mean that we are stuck with a model where some people can afford this and others can't. And that, again, creates more inequality. There are lots of issues of bias. Again, I didn't talk about that. There are also greater implications for education and training. For instance, in a talk to some like law firms where they say, typically you have this junior associates and senior associate and partners and so on. There's kind of a hierarchy. The benefit of that is there's a training that's constantly happening. So if they were to deploy agents, it would be easy to replace, or rather more meaningful to replace the junior associate or the researchers, because the agents can do that kind of research. That they can compile case summaries and do all this research, and that's what often the senior associates are delegating to those junior or the entry level associates. So they could be replaced by the agents. But if you do that, how would you then create senior associates or more trained professionals because they became trained through climbing that ladder, through having that experience. And so if you start replacing the bottom tier using using the agents, then you may not have the top tier to complete in the next generation or so. And this kind of goes back to that Maslow's hierarchy of needs that I was talking about, that it ideally, agents can allow us to get done the bottom level thing so we can focus on the top level thing. But what if those bottom level things are the ones that define us? So for me to drop off my kids at school, it may be a mundane task that I can delegate the agents to, but that's what helps me define me and my day and my identity. And so taking that away is not necessarily a good thing for me. But again, we haven't thought this through enough. And so there are a lot of these implications on individual level at the generations and that we haven't talked about. So at least I didn't talk about in this talk, but I just want to acknowledge there are a bunch of things that needs to be paid attention to. With that, I want to start wrapping this up, and hopefully there are some questions. You can once again send those questions to townhall@uw.edu. So agents are here, whether we like it or not, but there's a way we can move forward in a responsible manner. And once again, I'll put a plug for Raise at UW. If you're interested in these kind of topics, please check it out, where we do care about doing things in a responsible fashion, not resisting it, but also not buying into the hype and not going into it blindly. So we need to ask why, how, and then what? Why are we building agents? How are we going to do this? And what does it mean? What is the implications on my area, my job, my field, the world, to the extent that we can think? If you're building this, we better do it the right way, a better way rather. And that means focusing on the users, because ultimately the agents are meant to be the delegates of the users. And so we need to first understand the users, their tasks, their context, before we start delegating it to these agents, rather than getting excited about what kind of great agents we can build and then go look for applications. And then finally, we need to really think through these trade-offs. What are we giving up to gain that ability, to gain that personalization, proactiveness? How much of the privacy are we willing to give up to gain that capabilities and saving time thing? How much of the agency and control and even identity of who we are able to, or we are willing to give up? But that being said, there are tons of economic opportunities. So now I want to kind of talk about a little bit of a positive side of this, that there are lots of economic opportunities for individuals, companies, and countries to increase their productivity, to be more efficient, to reduce workload. And so there are lots of opportunities. And final thing I would say is there are advancement opportunities for new players and startups, because unlike the LLMs and many of these foundational models that are very expensive, very hard to build, agents are giving people, anyone, any ordinary people, a chance to build something meaningful, valuable. And so I talked to a lot of startups and a lot of individuals even who are building things around this. And so this has lowered the bar entry for building these kind of services for technology. And so that's great advancement opportunities, and we need to grab it. And I really encourage, there's a lot of opportunities here for students, for new players, and it doesn't need to be just big tech companies. Even those who are coming from non-tech backgrounds, non-traditional developers, they also have great opportunity for advancement here. So with that, I want to thank you for your time and take any questions we have. Okay, so I'm going to take a question that I see. Is it possible to meaningfully regulate or legislate agent behavior and capabilities? Is regulation of agentic AI futile in practice? I think I kind of already answered this. I think the regulatory efforts are pretty slim to none when it comes to agentic AI, especially in the United States. There are some efforts in EU and Australia and some other countries, broadly speaking, for AI. But I don't think, the short answer is no. I don't think that's going to be enough. Is it possible? if I have to pick yes or no, I would say no. A lot of these things is because it's a moving target. It's a constantly changing, shifting domain. As I said, even what agent is not well understood. What the hope is here is instead of having a broad framework for regulating agentic AI, we would have, and we are already starting to have, specific framework for a specific domain. So, for instance, in transportations, you have framework for self-driving cars. Testing it, deploying it. Again, there are a lot of issues there too, but there is something there. Similarly, in healthcare, so I don't think there's going to be something across the board because I would say it's not possible. But within a framework, because you do need domain knowledge. What does it mean to regulate an agent in healthcare? That may be different than what is it to regulate an agent in education or in workforce and so on. So I think those are more kind of likely to happen. That does mean that not every domain will have regulations. Can you speak about groups of agents that collaborate together with the people as a team? Absolutely. So this is actually a big thing right now. So multi-agent system, and I didn't go into details of it, but multi-agent system is where you have different agents with different capabilities working together, typically orchestrated by another agent and solving complex tasks. But there are also these hybrid systems where agents are part of a team or taking responsibility. One simple example is, say, in Microsoft Teams, you have an agent that takes the notes. And actually, it's not just in Microsoft Teams. There are many other software products where you have a note taker for a meeting. And so this kind of serves as a part of your team and can take not just the notes, but also create insights from the meetings and across multiple meetings and multiple people. We are starting to see these things in medical diagnosis, where an agent is there in the room with the doctor-patient interactions, taking notes and compiling, case summaries and helping with the diagnosis. So I think to me, this is a lot more appealing case than simply delegating things to an agent as a black box. To have typically we'll talk about human in the loop, but this is sort of agent in the loop, that it is still a human endeavor. The humans are still running the things, but they are starting to use agents as an entity, as a collaborator in those things, as a tool or collaborator. And this is what I was reflecting towards the end, those three principles of confirmation, consulting, and collaboration. So I think I'm very positive about it. Some of those are already happening, and I hope that more of that can happen. Will the slides and a reference list made available to lecture reading? Yes, I think the UW-IT will take care of it. They're telling me that if this would be, this is being recorded, this will be available in the UW-IT's YouTube channel, and there would be, I guess, things linked through that next week. I think we have time to take maybe one more question. Agentic models are autonomous and make decisions on our behalf. How do we ensure they behave ethically, especially when ethics vary across cultures and contexts? Great question. And I wish, this is one of the things that I skipped, as I said, reflected toward the end, that I didn't get a chance to go into some of these issues of bias, fairness, in general ethics. Unfortunately, not many people are focusing on this. And you can kind of imagine why. But we know in our experience, in our research, and of course, many other people's research, that things are different culturally across different domains, in different cultures, different countries, languages. And so unfortunately, ignoring those things can result in big disasters. And they're already starting to happen. So I will repeat the main point of my talk, and maybe I'll end there, that's why we shouldn't be focusing on building agents. First, we should focus on understanding people, their context, their tasks, their culture, and then ask how we can take this to an agent rather than the other way. Unfortunately, a lot of the efforts that I see are going the other way. They're trying to fit something to people and their context rather than going from people and context to the agent. So that would be my message. And I think we're at time, so I'm going to end here. But thank you so much for joining me today. And if you have any questions, have any comments, please feel free to follow up with me. Thank you, everyone.